Thank you so much for watching this online video tutorial. Please like, comment and share the video, and please don't forget to subscribe to our YouTube channel at Good Better Best Online Videos for more content. Good day guys, and thank you for joining us. So in today's lesson we'll be looking at some revision for our trigonometry. So we're going to look at getting through basically all that we've learned throughout this video series right here on trigonometry. So for the first question here, it says identify the type of graph and give the equation. So the reason now why I've put the type of graph in there first, because that's basically your first step to finding which equation it is. Because once you know which graph it is, all you're looking at after that is, has the amplitude changed and has the graph been shifted at all? So what I want you guys to do is pause the video right here, give these two examples a shot, and then when you are done you may unpause and then you can go through it with me. Shouldn't take you that long. Cool. Okay guys, so now that you've done the examples, let's have a look at the answers. So the first thing we're going to look at what type of graph it is. Straight away we can see that the graph has a turning point on the y-axis, right? And that is characteristic of the cos graph, right? So we can write here so long y is equal to cos, leaving space for in case there's an amplitude change or if there's a shift, okay? So we know it's a cos graph, right? Then what else can we tell? Let's see if there's an amplitude change first. Is the amplitude change? Yes, there is. Because remember, normal amplitude is 1. So this graph would go up to positive 1 and down to minus 1. But because it's 3 now, going up to positive 3 and minus 3, that means that the amplitude has changed to 3. The graph also hasn't been flipped upside down or been inverted on itself, which means that this is positive 3, okay? Remember that if the graph has been flipped upside down, then we'd have a negative in front of here, okay? And has the graph been shifted at all? It does not look like it, right? Because it still goes through 90 degrees on the x-axis and 270 degrees on the x-axis as well. So that means that our final equation for this graph is y is equal to 3 cos x. Cool? Now let's go ahead and look at our next one. We can see here that the graph goes through the y-axis, but it doesn't have its turning point on the y-axis. Therefore, we know that this is going to be the sine graph, right? So we can write here so long sine. And then, has there been an amplitude change? Yes, there has. The amplitude of 2. And then we can also see that we know once the graph goes through the y-axis, it's actually going up. It's supposed to be going up if it's a sine graph, but you can see it's going down instead, which means that this graph has been flipped upside down or opposite, so which means that this will be the minus graph. Okay, so it's minus 2 sine x. Is there any shift? No, there isn't, because the graph passes through the x-axis here at 0 and at 180 degrees and 360 degrees again, confirming that this equation is equal to y is equal to minus 2 sine x. Now let's move on. We're moving on to this example over here. So this is an example of where we get a shift and an amplitude change, where we can't really pin down what the equation is. So they say here, they've given us y is equal to a sine x plus q. So they've already told us now that this is a sine graph. But what do we do in the circumstance where we just get given these 2 points? So what we're going to do is we're going to use these 2 points, and we're going to make an equation out of this point by substituting in this set of coordinates, and then we'll make a separate one substituting in these coordinates, right? And we'll use this equation as a base. And once we've got those, you'll see what we're going to do with them. So we're going to first substitute in our first set of coordinates, which is 30 degrees and 0. Obviously 0 because it's on the x-axis. So obviously now y is going to be equal to the 0 over here. So 0 is equal to a sine 30 degrees plus q. So now we go ahead and simplify this. 0 is equal to sine 30, we know is going to be equal to a half if we use special triangles, but our calculator will also tell us that. And so a half times a will give me a over 2 plus q. And then we'll say that this is our equation number 1. Moving on from here, we're going to put this into an equation now. So we're going to use the points 270 degrees and minus 3. Cool? So obviously now y is going to be equal to minus 3, which is equal to a sine 270 degrees plus q. So what I want to do now is I want to isolate 0 on this side of the equal to sign and get everything over to the right hand side, which is going to make the next part of this example easier. So once that goes over, it becomes minus 3. Sorry, it becomes positive 3, because remember, minus going over, it changes sign, so this is going to be 3. And then what happens is sine 270 in our calculator will give us minus 1. So minus 1 times a gives me minus a plus q. And this will be my equation number 2. What we need to do with these two equations now is we need to minus them from each other. So I'll minus equation 2 from equation 1. So I'll say equation 1 minus equation 2. And what that looks like is 0 is equal to, now you see why I isolated the 0, it makes it easier for us. So now it's 0 is equal to, so we'll put equation 1 first, a over 2 plus q, minus, and then equation 2 will be in brackets, so this minus will times into this whole equation 2. Cool. So now what happens is, once we simplify, we have a over 2 plus q, the negative going in gives me minus 3, then that's plus a, and this is minus q. Simplification will make it that minus q cancels with positive q. And then we'll take this 3 over to leave the a's by themselves, so this will be positive 3 on this side, and we have a over 2 plus a, so that's basically saying a half plus 1, which gives you 3 over 2, so this will be 3a over 2. Now we need to isolate a, so we're going to times by 2 both sides, so we get 6 is equal to 3a, and to get a by itself we divide by 3 now, and so therefore a is going to be equal to 2. So now that we've got the value of a, we need to find the value of q. Remember, this a is going to be our amplitude, so the amplitude of the graph is actually 2. Let's use this a now to find the q value. So we'll say sub a is equal to 2 into equation number 2. You can even do it into equation number 1. I'll just be doing it with number 2. So here's my equation number 2. So I have 0 is equal to 3 minus a, which is 2, plus q. So I'll take this 3 over, it becomes minus 3 is equal to, negative times 2 gives me minus 2 plus q. And so once this 2 comes over, it's going to be positive 2, so it's minus 3 plus 2. So therefore q is going to be equal to minus 1. And that tells us that the graph shifted 1 unit down. Once we're done with that, we can write out our final equation here, which is going to be y is equal to, what is the a value? It was 2 sine x minus 1. And that is your final equation, an amplitude of 2, and it's been shifted 1 unit down. So now moving on to this example here, guys, I want you to pause the video and then give yourself some time to answer, and then unpause and I'll go through it with you. Okay, now that you've had a chance to go through these examples, let's go ahead and answer them. So first thing we want to do is construct our triangle. We know that this is these coordinates, this is the x value, this is the y value, so that means that on the x-axis we've gone 5 units from the origin, right? And since we started at origin, we know that this is 5 units in length. And then we also know that from here to here is 12 units up, right? So this is going to be 12 units in height. And what we need to find now is the hypotenuse if we're trying to determine sine, cos, and tan theta, right? Because obviously we need the hypotenuse to determine these ratios as well. So we're going to find the hypotenuse, so we go h squared is equal to 5 squared plus 12 squared. So if we go on, it's going to be 25 plus 144 is equal to 169. And so to get h squared by h by itself, we have to square root to get rid of that square, which is the one side to the other side, and so our hypotenuse is going to be equal to 13. Now we need to write out sine theta, which we know is equal to opposite over hypotenuse, cos theta, which is equal to adjacent over hypotenuse, and tan theta, which is equal to opposite over adjacent. So all we need to do now is substitute in these values. So obviously we have theta over here, right? So this is going to be the opposite side, this is going to be the adjacent side, and this is going to be the hypotenuse. So opposite is going to be 12, hypotenuse is going to be 13, which we worked out, right? Then we have adjacent, which is 5, and hypotenuse, which is 13, and then an opposite, which is 12, and adjacent, which is 5. So it's pretty easy once you've named your sides and also you have your equations written out here. Now we're going to move on. We're going to do basically the same thing here. Remember, you can construct a triangle in any direction. It won't change your answer. I'll construct it in this way over here. So this is going to be minus 12 and this is going to be minus 5. We need to find out the hypotenuse, right? And the reason I've left it as minus is because when we do our ratios, we don't want to get confused and get this wrong, okay? Rather leave it as a negative, because when we put it into the equation here, the Pythagoras equation, minus 5 squared is still going to give me a positive number to work with, okay? So then we go h squared is equal to 25 plus 144. You see they're positive now. So h squared is going to be equal to 169. Square root to get h by itself, h is equal to 13. So we write that in there. So now we go again. Sine theta is equal to opposite over hypotenuse. Cos theta is equal to adjacent over hypotenuse. Tan theta is equal to opposite over adjacent. So now we just refer to this picture over here to help us answer here. So our opposite side, so we're going to just quickly name it. When the angle's going all the way around, we're going to use the angle that's closest to the origin to represent theta, okay? So we'll represent theta with this angle, because the other two angles of this triangle are too far away from the origin. So which means this is our opposite side, this is our hypotenuse, and this is our adjacent side. So the opposite is minus 12, and the hypotenuse is 13, which is positive. So which means that this whole fraction, if it's a negative and a positive, it's going to be a negative fraction. So this is negative 12 over 13. Is equal to adjacent over hypotenuse. This is a negative 5 over positive 13. So this is a negative 5 over 13. And then for tan theta, we have opposite over adjacent. And this is opposite, which is minus 12, adjacent, which is minus 5. Those are both negatives, which means that we get a positive answer. So that's going to be 12 over 5, positive, right? And so now you can see why it was important for us to include these negatives here, so we didn't get confused, because this answer was negative 12 over 13, this was negative 5 over 13, and this came to positive 12 over 5. Now moving on to the next example here, they ask us to solve for x, okay? And so if you can remember in our latest video, we looked at how we solve these triangles. And so what we have to do is look at what we are given. So we'll write here, we are given. We are not given the angle, right? We're given two sides here. So let's look at the sides. Relative to this angle, we are given the opposite side and the hypotenuse, obviously, which is opposite the right angle. So we're given the opposite side, which is 12, and we're given the hypotenuse, which is 16. What we need to find, though, is theta, which is equal to x, which we need to find. So what we need to look at now is our SOHCAHTOA, which helps best in this case, and see, okay, we have opposite and hypotenuse. We're working with those two sides, and that means we're working with the sine ratio, right? There's opposite and hypotenuse next to the S for sine. So we write sine theta is equal to opposite over hypotenuse. And so what we'll do is now substitute in everything that we know, and then find out what we don't know. So sine, this is going to be x over there, is equal to 12 over 16, right? And so what we need to do now is just solve for x. And the way we're going to go about doing this is we're going to shift sine away from x, right? So whenever we're trying to get a ratio away from x, we're going to shift it. And what that looks like on paper is sine to the negative 1, and then we put in brackets the 12 over 16. So the way you get this function, if you can remember from the last video, is we press shift and then sine, and that's why we call it shift sine, and your calculator should show this over here. Then once you've plugged all of those into the calculator, x we know will equal to 8, 0, my bad, sorry guys, it's going to equal to 48, 59 degrees. Cool? And so what you need to know also is that whenever we are shifting sine or shifting any ratio, we are working out a angle. So that's why we'll always have degrees after we shift sine, tan, or cos, right? So that's basically how we get to this answer. Now we'll look at the next one here, guys. We can see we're given this angle 28 degrees, and we are also given the adjacent side here, right? What they ask us to find is the opposite. So we're going to just write down here what we always do. We write given. So we're given theta, which is equal to 28 degrees. And then we are also given the adjacent side, which is 14. What we need to find, though, is the opposite side, which is equal to x, which is what we need to find. And so if we're looking, we have opposite and adjacent that we're working with. Opposite and adjacent correlate with the tan ratio. So we'll write tan theta is equal to opposite over adjacent, right? Then we'll substitute in what we have to find what we do not have, right? Okay, so once we plug that in, it goes tan 28 degrees is equal to opposite, which is x, over 14. And to get x by itself now, we need to times by 14 on both sides, remember, get rid of that bottom fraction. And so what that's going to give us on the left hand side now is 14 tan 28 degrees, which is equal to x. And so what you're going to do is plug that whole thing into your calculator, 14 tan 28, and your final answer that you'll get is 7,44. So remember, we didn't shift tan in this case. That's why we don't get an angle here. We don't get a degree. We're just trying to find the length of a side. And so our final answer here is 7,44. So now we'll move on to question 4 here, and it says solve for x. So what you're going to do is you're going to pause the video here. Once again, just go through it, try and answer all the questions, and once you're done, you can resume the video and I'll be going through it. Okay, so now that you've gone ahead and done those, let's walk through this and see how it goes. So what's going to happen is we're just going to try and get x by itself, right? And so to do that, firstly, we need to get it out of this fraction. To get it out of the fraction, we need to times by 4 on both sides. And so what we're left with on the left hand side is sine x, which is equal to 4 cos 88 degrees. And so what's pretty cool is we don't necessarily have to find the answer for this just yet, because what we can do is shift sign straight away. So we get x is equal to sine to the negative 1, and put in brackets here 4 cos 88. So you're going to press shift sign, and in that bracket you'll put in this 4 cos 88 degrees, and then you should get the final answer here of 8,02 degrees. Because remember, we shifted sign, so we were getting an angle. That's why we have degrees for our answer. And if you go ahead and check it, you can find the answer for 4 cos 88, and if you plug that answer into shift sign, you'll get this exact same answer. So that's just a neat little trick there. Moving on to 4.2, what we can do here now is straight away just shift cos all the way across to that side. So we'll leave x over 2 on this side, which is going to be equal to shift cos, and then in the bracket sine 50 degrees. And so then what's left over here, x over 2 is going to be equal to 40 degrees. Once you put that in your calculator, you'll get 40 degrees. To get x by itself, we'll times by 2 both sides, and then we get x is equal to 80 degrees as your final answer. So now moving on to the last one here, we have tan x is equal to, so very interesting here, we know that sine over cos is equal to tan. The only thing is that we need to have right is the fact that both of these angles here have to be exactly the same. If these angles are different, we can't convert it to tan, because then it doesn't have the same value. But because in this case they both do have the same angle, we can change this straight into tan 18 degrees. And you can check that even if you work it out separately, you'll still get to the same thing. If you do sine 18 over cos 18, you'll get the same as tan 18's answer. So from this point, what we can do, get x by itself, shift tan immediately across, tan negative 1 and tan 18 in the brackets. And so our final answer will be 18 degrees. And that's your final answer, guys. Now moving on to our last question, we have determined the value of the following without the use of a calculator. So that last part should give you a hint at what we're busy with, okay? So anyways, go ahead and pause this right now and give it a shot, and then once you're done, you can unpause it and then follow along with the explanation. And so that last part that says without a calculator should tell us that we're using our special triangles. And so without it looking too fancy, because it really doesn't have to be, they just need to know that we are referring to our special triangles, right? We know that we have a 45-degree one, which is 1, 1, and root 2. And then we know that we have one that is 1, root 3, and 2. And this is going to be 60 degrees over here and 30 degrees over here. And that's practically all you have to remember, right? So now, moving on to our example here, we need to break this up for ourselves. Tan squared 45 degrees minus cosec squared 45 degrees. So if we can recall, cosec is the inverse of sine, okay? So what we're going to do is we'll still go ahead and find sine 45, but then we'll just invert it, right, at the end. So let's go ahead and do this. We're going to say, firstly, this is going to be tan 45 degrees squared minus cosec 45 degrees squared. Okay. So let's go ahead and find tan 45. Tan 45, here's our 45-degree angle. Tan is opposite over adjacent. Here's the opposite. Here's the adjacent. So that's 1 over 1. So this is just going to be 1 squared. Minus, so cosec, remember we said we're going to find sine 45. Sine 45, here's 45 degrees. So that's opposite over hypotenuse. So it's going to be 1 over 2 if it was sine, but remember it's the inverse, so it's root 2 over 1, which is just root 2, right? Squared. And so once we go ahead and solve these, we get 1 minus, so now remember that square root will fall away to the square, so this is 1 minus 2, which is equal to minus 1 is our final answer there. Then we're going to move on to our next ones over here. We have 3 tan squared 30 degrees minus a third sine squared 60 degrees. Now this 3 and this third in front basically means timesing, okay? So let's just break it up quickly, like we did the previous one. So we have 3 tan 30 degrees, once we find that we'll square it, minus a third sine 60 degrees, and then we'll square it. Cool? So let's go ahead now and look at it. So we're finding tan 30 first. That's going to be 3 times whatever tan 30 is. So here's 30 degrees over here. Tan is opposite over adjacent. Here's the opposite side. Here's the adjacent side. So it's 1 over root 3. That's going to be squared. Minus a third times sine 60. Here's 60 degrees. Opposite over hypotenuse. So that's root 3 over 2. That's going to be squared. And so once we times these into the bracket 3, before we times it into the bracket, guys, what we need to do? We need to square it, right? So if we square what's in the bracket over here, this is going to be 1 over, so the root 3 becomes 3. And then we have minus a third times, once we square root all of these inside here, it becomes 3 over, now the square of 2 is 4. And so what's going to happen now is we're going to times the brackets out. So 3 times a third gives me 1, minus, so we're going to go 1 times 3 gives me 3, 3 times 4 gives me 12. And I also know that a 3 over 12 is also equal to a quarter. And so I know my final answer here will be 3 over 4. And just like that, guys, we finished our revision lesson. I hope that this has been informative and it's helped you to revise your trigonometry really well and that everything makes sense. Anyways, guys, thank you very much for joining us, and I'll see you in the next one. Bye.